Preventing Rusting by KayScience.com. Rusting is the corrosion of iron when iron reacts with oxygen and water to form hydrated iron-free oxide. Here I'm drawing a block of iron, and surrounding the block of iron is oxygen and water in the air. This oxygen and water reacts with the iron to form hydrated iron-free oxide. Over time, the soft rust flakes off. Causing the iron to weaken as the iron is corroded. To prevent rusting, the iron can be painted. The paint acts as a barrier to the oxygen and water. Not only this, the iron can also be covered in oil or grease. The oil or grease also acts as a barrier to water and oxygen in the air, which cannot get through to the iron, as the coatings act as a barrier by stopping water and oxygen getting to the iron.
It's question time. Attempt these questions to check your understanding.
Galvanized is when iron and steel are protected from rusting by a coating of a thin layer of metal, for example, zinc at the surface. To explain what galvanized means, here is a block of iron, and when this block of iron is galvanized, it is covered by a coating of a thin layer of metal. In this example, it is coated in a more reactive metal, for example, zinc, which is a barrier to the iron. Now, in this second example, iron can also be covered by a thin layer of metal which is less reactive than the iron. So in this example, the iron is coated in a less reactive metal which is a barrier to the iron. The iron is covered by a thin layer of metal using electroplating or being dipped in molten metal. So when iron is galvanized by a more reactive metal, this means the water and oxygen reacts with the more reactive metal on the outside, protecting the iron on the inside. And the iron galvanized by the less reactive metal means the water and oxygen does not react with the less reactive metal on the outside, protecting the iron on the inside.
It's question time. Attempt these questions to check your understanding.
Here I'm drawing 3 test tubes labelled A, B and C. Each test tube contains an iron nail, where we're going to investigate which is the best technique to prevent rusting, painting or galvanizing an iron nail. In test tube A, the iron nail is painted. This is a painted iron nail which is submerged in water and also is exposed to air. There is no bung in any of the test tubes. Test tube B contains a painted iron nail which is scratched, submerged in water and exposed to air. This right here represents the scratched, painted iron nail. Like the first nail, it is submerged in water and exposed to air. In test tube C, we can see the iron nail is galvanized with the more reactive metal zinc. However, there's a scratch. Here we can see there's a scratch on the galvanized nail with zinc. And again, this galvanized nail with a scratch is submerged in water, and again it is exposed to air. The conditions are the same in each test tube. Now in test tube A, there is no rusting as the paint is a barrier to the water and oxygen. In test tube B, the nail has rusted where it is scratched as the iron is exposed to water and oxygen, forming hydrated iron-free oxides on the scratch. And in test tube C, there is no rusting as galvanizing has stopped rusting as zinc is more reactive than iron. So zinc reacted with oxygen and water where the scratch is. So zinc oxide formed where the scratch is. This is because zinc is more reactive than iron. Zinc has a stronger tendency to lose electrons compared to iron, so will react with the oxygen first. There are many situations where there are harsher conditions with lots of water. For example, this iron ship is exposed to lots of air and water. This means bars of magnesium are attached to the ship. Here I'm drawing the bars of magnesium which are attached to the ship. Now, because magnesium is more reactive than iron, this means magnesium sacrifices itself to protect the iron. So it's the magnesium which reacts with the water and oxygen before the iron. This process is known as sacrificial protection. In this second example, here I'm drawing an iron wheelie bin. This iron wheelie bin is coated in zinc. This is because iron wheelie bins are normally exposed to a lot of rainwater and air. And what happens as the iron wheelie bin is used, it is scratched a lot as it's moved about often. And these lines represent the lots of scratches. The iron is protected because the zinc metal sacrifices itself to protect the iron. This is another example of sacrificial protection.
Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.